We're gonna weigh 1 gram of sodium bicarbonate in order to prepare 10% of sodium bicarbonate solution. The solution is used to power the sodium hypochlorite.
So it is 1 gram
Yep.
of
Sodium
sodium
bicarbonate.
bicarbonate
Yep.
for 9 millimeters.
Yep. This is weight.
Milliliters of water.
Yeah. This solution is considered weight to volume ratio. Just consider 1 gram of sodium bicarbonate in 10 ml of water. And that's what weight to volume ratio is. And for sodium bicarbonate, it takes a little bit of time and shaking in order to get completely dissolved. So you have to make sure to invert it for like 3 to 5 minutes to get completely dissolved. Solution to adjust the pH of sodium bicarbonate. This solution can serve as a power solution to reduce the pH. The regular pH of sodium hypochlorite is around 11, and we need to bring it down to 9 pH. And we're going to use these solutions to adjust that pH. The reason of using this solution is because it has no side effect pretty much, and no damage for the living tissue. Instead of using hypochlorite, which is have some effect on the living tissue, so we're going to use sodium bicarbonate to adjust the pH. Okay, and in this step now we're preparing 0.5% concentrations of sodium hypochlorite. The stock solutions of sodium hypochlorite called bleach, it's come with 8.25% concentrations. In order to make the final concentrations of 8.5% of sodium hypochlorite, we need to use this formula. This formula considers concentrations 1, which is 8.25%. That's the stock solutions. The volume 1, which is that's where we try to figure out the concentration 2 here. It's the final concentration, which is 0.5% of sodium hypochlorite, and the volume 2, the desired concentration that we want to prepare. In our situations, we want to prepare 10 ml of 0.5% of sodium hypochlorite. We have the stock concentrations 8.25, the final concentration 0.5% of sodium hypochlorite, the final volume of sodium hypochlorite 0.5% concentrations, and the volume 1, which is we try to figure out. We like all these numbers in this formula, and we get to this number 0.61 ml of sodium hypochlorite plus 9.38 ml of water. We're gonna have a final concentrations of 0.5% of sodium hypochlorite. Okay. I'm adding 9.39 ml of still water under the hood to my test tube. It's preferred to use the 50 ml test tube in order to have it fit properly with the pH meter prop, because the diameter is wider than the 15 ml test tube. Then we're gonna add 60.61 ml of sodium hypochlorite, the stock solution, which is 8.25 ml. Now we have 0.5% of sodium hypochlorite, 10 ml of volumes, but it has unknown pH, so we're gonna clean this.
So here right now we're getting the
pH.
pH of the 0.5 sodium hypochlorite, the solution that you prep.
Yes, sir.
Okay. And we wanna adjust it down to 9
9 pH.
pH. Okay. And we are going to adjust the pH with the sodium bicarbonate.
Now we try to adjust the pH of 0.5% of sodium hypochlorite. The final pH of the unpuffered sodium bicarbonate is almost 10.8. So we're gonna use sodium bicarbonate to adjust that pH and drop it down to 9 pH. So we're making sure that our sodium bicarbonate is completely homogenized. And before we add, we're gonna do read so we can watch our pH live.
Lower than 9.
We need to bring it up. We use the basic solution. We normally use sodium hydroxide. Normal pH of 1 mole of sodium hydroxide is around 13 pH, and that's what we use to adjust the pH up.
Okay. Drop by drop, right?
Okay. And you observe the monitor of your pH meter.
So how many drops have you added already so far?
I add almost 8 drops right now,
8 drops?
but it depends on the final on the total volume of your buffer that you want to prepare. So I think with 2 more drops.
Seems like we have finally reached the 9 pH. So now we have our dakin solution ready. It's a 0.5 sodium hypochlorite with a pH of 9. Okay, thank you, Ali.
You're welcome, doctor.